Hello, my name is Campbell Doman, and I'm going to be teaching you about stoichiometry. So, some things that stoichiometry can be in real life, it's really in our everyday lives. It's in things like chocolate, fertilizers, and even deodorant. And those are just, there's many more things like gasoline and all that, but, really, you don't really see it. You don't really think about it too often, but it's really in our everyday lives, all the time. We're always using it. And so when we talk about stoichiometry, there are, a good amount of things that we need to cover. We can go through these. This is called the limiting reactant. So I'm going to use a little diagram here so I can show you so it's a little bit easier to explain. The limited reactant, LR. Limiting reactant, so let's say you have a sandwich. It's a lot easier way of explaining it. If you have a sandwich, let me get a little diagram here. So you have a sandwich, and on your sandwich, you like cheese and ham. You like ham and cheese, a ham and cheese sandwich. So we have let's say this is our cheese, this box here. That's our cheese, and this is our ham. All right. So in this equation, we know that one cheese plus one ham equals a sandwich. That's pretty basic. So now let's say you have two cheese and 3 ham. Okay? So what this is saying is you can make, how many sandwiches can you really make? If we know that one cheese and one ham makes one sandwich, and we have 2 cheese and 2 ham, we can ultimately make 2 sandwiches, right? So we'd say that, what are we limited on here? Like what things are we limited? Like what's our limiting reactant? That's what we were talking about here before. Our limiting reactant is our cheese, because we don't have enough cheese to make one more sandwich for this ham, right? We don't have enough. We need one more. So it's limiting us from making another sandwich. That's why it's called the limiting reactant. And what else we can talk about is the excess reactant. The excess reactant is this ham right here. It's what we have after we've made our final product. And this final product is called the theoretical yield. Sorry. So the final product is a theoretical yield. And so our theoretical yield in this equation would be 2, because we can make 2 sandwiches. Our excess reactant would be 1H, which would mean 1 ham, and our limiting reactant would be 1 cheese, which is cheese. And then we get to actual yield and percent yield, which are some of the more harder to explain things. So an actual yield is like a quantity of a product. So it would be like it's like the quantity of your final product, and it's obtained from having a chemical reaction. So you can't have it without a chemical reaction, really. And a percent yield is like the whole percent of your theoretical yield. So it's the whole percent of how many sandwiches you really have. So now that I've explained all those yields, and I hope you guys get it, we're going to do a stoichiometry problem here. Oh, hopefully this doesn't fall over here. My setup isn't the greatest. I don't have time to do this again. Okay, there we go. So, let's do our own stoichiometry problem. So we're going to use barium hydride. So, BAH, barium hydride, right? And so BH3. And so what we're going to do is we're going to find the molar mass of barium hydride. And I've already, pre-done this, and I know that it's 100, I hope this stays still here, 139, we use it in grams, right? And then 0.34, right? That's the mass. That's the mass of this barium hydride, which is what we have. And we want to know how many moles we can form, which is our theoretical, how many moles we can form of this barium hydride, right? So what we're going to do is we have 15 grams, right? 15 grams. What we have to do is we have to take this barium hydride, right? And so when transitioning from grams to moles, we have to divide by the molar mass. So we take the 15 that we have, we take the grams that it gives us, right? We take whatever we have and we put it over what we want to get rid of. Well, technically not what we're going to get rid of, but our mass, right? Our molar mass, the mass of BaH3. So 15 over 139.34. Hopefully you can see that okay.